Good afternoon. I am Marina Lobach, the scientific supervisor of the MAGUS project. Today, I would like to present to you an overview of the MAGUS Bio 240 series biological microscopes, which feature intelligent illumination control. Setting up these microscopes does not take much time, so these models will be of interest to both educational institutions and clinical diagnostic laboratories, where hundreds of samples are examined every day. Imagine a laboratory class in a biological or medical university. 15 to 20 students are sitting at microscopes. The instructor's task is to teach them to distinguish, let's say, a fly's leg from a bee's leg. All right, let's be more serious. An eosinophil from a neutrophil. The student adjusts the viewing head. So far, nothing seems too difficult. Then they center the condenser and set it to the correct height, adjusting the aperture and field diaphragm. The microscope shows nothing. And then the student remembers that they were supposed to focus on the specimen first. After half an hour, the instructor loses patience and adjusts each device in the classroom themselves. The class ended, and the poor eosinophil was left unnoticed. Time was wasted. No big deal. Next lab session, the process will go faster. Not a chance. By then, the students will have forgotten the settings, and worst of all, they've already lost interest. Believe me, I know what I'm talking about. In seminars, we spend 3 hours studying theory. We study calculating the resolution limit for each objective, learning the difference between achromatic and planachromatic objectives, and comparing the field of view of various eyepieces. Then the practical session begins, and suddenly everyone forgets about resolving power, aberrations, and field of view. Everyone is interested in only one question. What am I going to look at under the microscope? The second question, what specimen does my neighbor have? This is a normal reaction for someone sitting at a microscope for the first time. They want to immediately see the microworld, but instead are forced to spend half an hour setting up the instrument. A love for color illumination comes with time, when you can set up the microscope in a couple of minutes and easily get an image at the objective's resolution limit. At the initial stages, it's important to maintain the student's interest, and for that, instruments with simple adjustments that still provide excellent images are best suited. In the MAGUS demo hall, there are about a dozen biological models, so students end up working on microscopes of varying quality. The first enthusiastic wow comes from the one sitting at the Bio 240. While the others are turning knobs and centering the condenser, this person manages to examine 5 study samples. A similar situation occurs with lab technicians who scan hundreds of samples every day. Routine work doesn't require a microscope with high resolution and shouldn't involve wasting time on unnecessary adjustments. Let me draw an analogy with cars. A race car driver chooses a car with a manual transmission. Someone who spends 2 hours every day commuting to work in city traffic, of course, will prefer an automatic transmission. A road trip enthusiast will be interested in yet another special feature, cruise control. Today, I'll tell you about a microscope with an automatic transmission and cruise control. One that saves the lab technician's time, helps teachers keep students engaged, and makes it easier for students to work with the microscope, freeing up more time for scientific pursuits. The Bio 240 series. For professionals who can't imagine working with a microscope without cooler illumination, we will offer reviews of other models. I'll talk about the automatic system a bit later. First, let's take a look at the optics and make sure that this is a serious instrument, not a children's toy. The microscope comes equipped with planachromatic objectives with magnifications of 4, 10, 40, and 100 times. The color coding matches the magnification. Red for 4, yellow for 10, blue for 40, and white for 100. Objectives with magnifications of 20 and 60 times are available by special order. Planachromatic objectives correct for 90% of field curvature. The eyepieces provide 10 times magnification with a field of view of 20 millimeters. Let me show you what 20 millimeters gives compared to the usual 18. 18 and 20 refer to the diameter of the circle. take a look at the image. The area of a circle is pi r squared. This means that the field of view of eyepieces with a diameter of 20 millimeters is 23% larger than that of eyepieces with a diameter of 18 millimeters. And if you take into account the field distortions of achromatic objectives, the difference becomes obvious. Students might not appreciate this, but for a lab technician, 23% is a significant advantage. A lab technician will be able to examine a larger field of view at once, which means fewer fields will need to be reviewed. In terms of working time, this means they can save from 45 minutes to an hour and a half. It's up to you to decide how to spend those 3/4 of an hour. Now, it's the perfect time to explain how the automatic box is implemented in a laboratory microscope. Take a look at the condenser. The condenser height is set at the factory. The condenser is centered relative to the optical axis and secured with 2 screws. The condenser does not require any additional adjustment. The fixed position eliminates the risk of accidentally changing the correct setting. A pre-adjusted condenser makes it easier for students to work with the microscope. This solves the problem I mentioned at the beginning. When switching objectives, you only need to adjust the aperture diaphragm using this lever. The digital and color coding of the objectives on the condenser helps set the aperture correctly. The user places the specimen on the stage, adjusts the focus, and opens the diaphragm according to the objective in use. Now, let's take a closer look at the revolver. The nosepiece has 4 slots for installing objectives. The nosepiece is coded. As with other MAGUS microscopes, the Bio 240 nosepiece is positioned facing away from the observer. This way, the user can see which objective is in the light path, and the space above the stage remains unobstructed. What does a coded revolver mean, and what are its advantages? Objectives with different magnifications transmit light to varying degrees. So when working with the microscope, you need to adjust the brightness each time you change the objective. Moreover, the image brightness in the eyepieces increases sharply when switching from a higher magnification objective to a lower magnification one. Switching from a 100x objective to a 4x objective causes a bright flash of light that can be blinding. That's why users remember to reduce the light source intensity in advance before rotating the nosepiece. Intelligent light brightness control solves this problem. MAGUS Bio 240 series microscopes remember the brightness setting chosen by the user for each objective and automatically set that brightness when the nosepiece is rotated. If necessary, the user can adjust the light source intensity. Intelligent control increases comfort and saves time. So, the condenser does not require adjustment, and the brightness is regulated automatically. So it's not just an automatic transmission here, but also cruise control. Another feature of the microscope's lighting system is its ability to change the color temperature. The color temperature of the light source can be adjusted from 3000 to 7000 Kelvin. The user selects a color temperature that is comfortable for the eyes, and if necessary, changes it by turning a single knob. The illuminator is equipped with a 3-watt LED with a lifespan of 50,000 hours. Pay attention to the liquid crystal display. The screen shows the magnification of the working objective, the brightness of the light source, and the operating modes, sleep and eco mode. Using the screen, the user selects the color temperature, locks the brightness adjustment, sets the sleep mode, and the auto-off timer. I've covered the main features of the MAGUS Bio 240. Now, let's take a closer look at the other nice little details. Visual attachment with infinity-corrected optics. The tube and attachments can rotate 360 degrees. The user selects the eyepiece height according to their own height. As I mentioned earlier, the standard package includes 10x eyepieces with a 20 mm field of view and long eye relief for comfortable use with glasses. Flat rubber eye cups protect the optics of glasses from scratches. Diopter adjustment is performed on the visual attachment. The diopter adjustment rings are located on both eyepiece tubes. The MAGUS Bio 240 series consists of 3 models, which differ in their visual attachments. If you need a microscope only for visual observation through the eyepieces, we recommend choosing the binocular model. If you plan to connect the microscope to a computer or television, choose the trinocular model. A digital camera is installed in the vertical tube with the imaging channel. The light path in the trinocular visual attachment is switched between 2 positions using this lever. The position of 100% to the eyepieces and 0% to the imaging channel ensures that the light source is bright enough for examination with any objective lens. The position of 0% to the eyepieces and 100% to the imaging channel protects the image on the screen from stray light. Our managers will help you choose a camera that suits your needs. The third model is binocular, with a built-in 8-megapixel camera. This model is suitable for classrooms. Children won't need to install a camera or switch the light path. Information is transmitted to the teacher's computer via USB or HDMI ports, as well as over Wi-Fi. The coaxial coarse and fine focusing knobs are positioned on both sides of the stand for right and left-handed use. Fine focusing is needed for precise focusing on the specimen and for refocusing the microscope when changing objectives or slides. The coarse focus lock mechanism is used to speed up readjustment of the microscope when changing the object of study. And the coarse focus tension adjustment mechanism allows you to set a comfortable level of resistance. For each user, another parameter of the focusing mechanism is the fine focus graduation value. On our microscope, the graduation value is 2 microns. For a student or routine microscope, this step size is optimal, as it ensures both speed and accuracy of focusing. Pay attention to the stage. The stage does not have a protruding rack along the x-axis. A belt drive ensures smooth movement and increases ease of use. The user won't accidentally scratch their hand on the rack. The slide holder is attached with 2 screws and can be easily removed for manual scanning. The side panels of the opening in the stand form handles for carrying the microscope with both hands. The device for hidden storage of the power adapter and cord enhances the aesthetics of the workspace and the safety of transporting the microscope. The compact and lightweight design makes it easier to store the microscope on classroom shelving. So, let's sum up. Planochromat objectives and 10x eyepieces with a 20mm field of view provide an image without spherical distortion at the edges. The pre-adjusted condenser makes working with the microscope easier. The coded nosepiece remembers the brightness setting chosen by the user for each objective and automatically sets it when rotated. The user can select a comfortable LED color temperature for their eyes. The MAGUS Bio 240 series offers 3 models to choose from, which differ by the type of viewing head: binocular, trinocular, and binocular with a built-in camera. By rotating the tubes, the user can adjust the eyepiece height to match their own stature. The coarse focus lock mechanism helps to quickly adjust the microscope after changing the specimen. And the coarse focus tension adjustment allows the user to select a comfortable stiffness for focusing. The object table without a protruding rail increases the comfort of work. The ergonomic stand ensures convenient carrying and storage. The original design, simple setup, and ergonomic features of the MAGUS Bio 240 models make this series attractive for educational institutions and routine work in clinical diagnostic laboratories. For scientific research, MAGUS offers more advanced models with dark field, basic contrast, with polarization, and DEC. Come to the MAGUS demo hall, bring your samples, and together we will choose the models that best suit your needs. Wishing you success in your work, colleagues.